Welcome to this tutorial on dispatchers in Kotlin Coroutines. Dispatchers are a fundamental concept that allow you to control where your coroutines execute. Think of them as traffic controllers that determine which thread or thread pool your coroutine will use for its execution. Understanding dispatchers is essential for writing efficient and responsive applications, especially when dealing with tasks like network requests, database operations, or user interface updates. So, what exactly are dispatchers? In simple terms, dispatchers determine which thread or thread pool a coroutine will use for execution. When you launch a coroutine, you can specify a dispatcher to control where that coroutine runs. This gives you fine-grained control over threading in your application, allowing you to run different types of work on appropriate threads. For example, you wouldn't want heavy computations blocking your user interface thread, and that's where dispatchers come in handy. Let's start with Dispatchers.Main. This dispatcher runs coroutines on the main user interface thread, which is crucial for Android and desktop applications. Any work that updates the user interface must run on this thread. In the code example, we're launching a coroutine with Dispatchers.Main and updating a text view. This ensures that the user interface update happens safely on the main thread without causing any crashes or exceptions. Remember, only use main dispatcher for quick user interface operations and not for heavy work. Next, we have Dispatchers.io, which is optimized for input-output operations. This dispatcher is specifically designed for tasks that involve network calls, file reading and writing, or database operations. These are operations that typically wait for external resources and can block the thread. The I/O dispatcher uses a shared thread pool that can grow dynamically based on demand, making it perfect for handling multiple concurrent I/O operations efficiently. In the example, we're reading a file and making an API call, both of which are ideal use cases for the I/O dispatcher. Dispatchers.Default is your go-to dispatcher for CPU-intensive work. This includes tasks like complex calculations, sorting large lists, parsing JSON data, or any computation that requires significant processing power. The default dispatcher uses a shared pool of threads, and the number of threads typically matches the number of CPU cores on your device. This ensures optimal performance for parallel processing tasks. Use this dispatcher whenever you need to perform heavy computational work that would otherwise block other operations. Dispatchers.Unconfined is a special and somewhat unusual dispatcher. It starts executing the coroutine in the caller thread initially, but after the first suspension point, it resumes in whatever thread the suspending function happens to use. This unpredictable behavior makes it rarely used in production code. The unconfined dispatcher is mainly useful for advanced scenarios or testing purposes. As a beginner, you should generally avoid using this dispatcher and stick with main, I/O, or default, which provide more predictable and controlled behavior. One of the most powerful features of coroutines is the ability to switch between dispatchers seamlessly using the withContext function. This allows you to start a coroutine on one dispatcher and switch to another for specific operations. In this example, we launch a coroutine on the main dispatcher, then use withContext to switch to the I/O dispatcher for fetching data. Once the data is fetched, execution automatically returns to the main dispatcher, where we can safely update the user interface. This pattern is extremely common and helps you write clean, efficient code that runs operations on appropriate threads. Let's recap the key takeaways. Use Dispatchers.Main for all user interface updates and interactions. Use Dispatchers.io for network requests, file operations, and database queries. Use Dispatchers.Default for CPU-intensive tasks like sorting, parsing, and complex calculations. And finally, Dispatchers.Unconfined is rarely used in practice due to its unpredictable behavior. By choosing the right dispatcher for each task, you'll write more efficient, responsive applications that make the best use of available system resources. Understanding and properly using dispatchers is a crucial skill in mastering Kotlin coroutines.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.